next part. In fact, I'm going to get my subtraction property of equality note card ready. I'm going to get my reflexive property of equality ready, and then I'm going to get my substitution property of equality, or property ready. I guess it is a property of equality. And then I'm going to get my transitive property, because we're going to do question 2 on page 282. That's the bell for right now. Not yours. You still need to be doing this video. Let's go. Okay, subtraction property of equality. Does it work for the angles? Right? We're going to consider each diagram and write a statement that applies each property to angle measures. Right? We want to know if we can mess with angle addition, angle subtraction, angle, etc. Well, let's start off with this one. Let's say subtraction property of equality. Let's look at angle AEC. So consider the measure of angle AEC. And a highlighter would be a good thing to use. So here it is, AEC. Let's also say, you know what? It turns out, maybe a little bit of measurement lets us know that AEC, the pink angle that I've got, and I've got a different color highlighter, is exactly equal to the measure of BED. And so hopefully that highlight color is coming in. We have equal to the measure of angle BED. B to E to D. Okay? There they are. They're the same size. They happen to have this overlap. And so this overlap is this part right here in the middle, right? This angle BEC. So let's subtract that away. And so with the subtraction property of equality, which says we have things that are equal, then we can subtract the same thing from both of them, and they'll still be equal. So in reality, I'm going to subtract this angle away, minus the measure of angle BEC from both sides. Measure of angle BEC. Well, what's left, right? What's left is this angle right here, AEB, and this angle right here, CED. Those are actually the same angle, right? If you started with a bigger angle and you took away, they're both, two angles that are the same, but you take away a common middle that they both share. Well, if you share equally and take away equally, then what's left, logically, have to be equal also. So we have then the measure of angle, this one right here, AEB, is equal to the measure of angle CED. Yeah, it works. Subtraction property of equality works for angles. You have a bigger angle, it equals another big angle, and you subtract away. Still the same. Let's go to the next one. The next one we need to talk about is the reflexive property. So I've got my reflexive property note card. I'm going to go into the reflexive property question. Here it is. The reflexive property is, there's just that angle. Just angle A. It's right here. Boom. Angle A. And if you look at angle A and you think about it as its own thing, all right? So then the measure of angle A has to equal itself. Okay. That's it. Substitution property. Okay, substitution property. So here's something that we know about substitution property. By the way, I'm going to bring up the note card for it. I wrote it down from the previous couple of videos. If A and B are real numbers and A equals B, then A can be substituted for B. So if we have this like expression and then we say that X is this other thing, it's actually known to be a 3, we can straight swap and put the X substitute and put the 3 where the X was. And the rest of it stays the same. We can start off by saying, look at that box right there in angle A. The measure of angle A is 90 degrees. Well, you know what? B also has a box, and the measure of angle B is also 90 degrees because they both have the boxes. So if they're both equal to 90 degrees separately, A is 90 and angle B has a 90 degree measurement, then aren't angle A and angle B the same? We're just going to straight swap. We're going to substitute that they both equal 90, so using substitution, they both must equal each other. The next part of this one finishes out question 2. It's important to get this question done, but it is on the next page. So page 283, but I didn't put that in the title of the video. You just move there yourself. It's the transitive property. Transitive property says you have three things. And if the first two are equal of those three things, and the next two are equal, so the second and the third, then actually the original and the last one, the A to C, those are also equal. So we're just going to build a chain of equality statements for the transitive property. We're going to say the measure of angle A equals the measure of angle B. All right, that's the first one. We're saying we can measure with the protractor, but we're saying that, you know what, I'm just going to call it those two angles are the same. But then I'm going to add to that, I'm going to say the measure of angle B is equal to the measure of angle C. So that's this angle, and that looks like brown grossness. Maybe I need to get my eyes fixed. Those two angles, we say those two angles are the same. Bear with me, think it through. If A and B are the same, because I said so, they also have one little arc mark, so they're the same type of marking in the middle. B and C are the same, then A and C. These two are actually the same also. So the measure of angle A equals the measure of angle C. That is, in fact, what the transitive property says. And so we've talked about the substitution property, the transitive property. We talked about the reflexive property. We talked about the subtraction property. We talked about angle addition. We talked about the addition property of equality. A couple of questions for you to think about after you watch this video. Thank you for doing that. What's the difference between the measure of angle 1 and the measure of angle, using notation, right? What does it mean if we said angle M, the measure of angle A, versus just straight angle A? Something to consider. What if we said from before, we said AB versus the measure of AB versus just AB? What would that do? What's the reason for those notational differences? Oh, pop quiz time. And then, do you think the angles you use, do you think that there's any overlap that has to matter? Do we have to have overlapping angles? Whoa. Do we have to have an overlap in the angles in order for us to use the subtraction property of equality? Probably not. All right, thank you for watching this video. Page 283 is the next video I'm going to share with you. We're going to do what we did with angles, but with segments. Yes, exciting. See you in the next video. Bye.